Welcome to Preparing Archives for a Changing Climate. This workshop today has 4 sections, and this is the schedule we'll go through. So the first hour, we're going to talk about Climate Change 101. This is the overview of the science and policy around climate change at a very general, global, and national level. Then we'll talk a little bit about climate grief and climate action in the second hour. Then there's an hour-long break, and then we'll come back and talk about climate change mitigation and adaptation within archives. So we're kind of going from like large, filtering down to the work that we do. And then we're going to get even more specific in the last hour and talk about California specific considerations. So that's the structure of today, and we'll see how many people are here in our group. But since it is such a small group, I would say I'm very comfortable taking questions whenever. Sometimes when I'm teaching in larger settings, I ask people to kind of hold their questions towards the end. But because this is such a cozy little group, that I think if anyone has a question, just raise your hand or put it in the chat box, which I'm also keeping an eye on, and we'll make sure that we accommodate that quickly.
Yeah.
So to introduce, I'm sorry, go ahead.
I'll be posting links in the chat as well. So if you have questions or if you didn't get a link, just check the chat and feel free to ask me. And if anybody has questions that they want to ask anonymously, that's absolutely fine. You can also always chat me directly, and I'll make sure that that we address them in the course of the workshop.
Well, thanks, Snowden. All right, so just as a brief introduction to add on to what Snowden had said. So my name is Eira Tansey, and I am joining you today from Cincinnati, Ohio, which is where I'm based. I've been an archivist for 15 years, and one of the things I always lead with when I'm introducing myself is talking about the watershed I live in, because I think that there is a lot to be said for recognizing the places that we live and how it's connected hydrologically to the larger world. So I always talk about how I am not just based in the municipality of Cincinnati, but I'm also based in the Ohio River watershed. And there's actually a little bit I'll talk about on watersheds towards the end of the workshop, based on a cool tool I found based in California. All right. So let's talk about Climate Change 101. So one of the things that I always do when I'm talking about climate change is making sure that everyone has a science-based grounding in climate change. When I work with archivists, I generally don't experience a lot of climate change denial, but I always think it's good to have a refresher on the current state of climate science, because archivists do tend to be trusted individuals in our community. And so it's incumbent upon us that when we are in spaces where maybe we are encountering some misinformation or disinformation, that we can say, well, this is what the current climate science shows us, because we are those trusted figures in many communities. So to differentiate between what weather is versus climate, weather is the day-to-day phenomena that occurs in a given location. So that is not the same thing as climate. Climate is sort of a long-term phenomena, and climate can change over time. And of course, that's why we're all here, is to talk about how the climate is changing, but it's not the same thing as what is happening day-to-day in a given location. And as environments change, so can climate change. So I live in the Midwest, and so one of the major climatological features we have in the Midwest is the Great Lakes. And the Great Lakes, because they are such a large body of lakes, actually influences the climate of the areas around it. So it has effects on summer and winter temperatures. It has effects on precipitation. If something were to happen to the Great Lakes, if they no longer existed for some reason, that would also have a large impact on the climate profile of the areas around them. So climate is always influenced by landforms, proximity to bodies of water, any kind of vegetation, and all sorts of other factors. And a common metaphor is that weather is like our day-to-day mood, but climate is like our personality. And of course, one of the major things that is happening is as we burn fossil fuels, that is changing our climate. So let's talk a bit about why that is. So the reason that we have what is known as climate change is because of something called the greenhouse effect. And the greenhouse effect actually is essential to life on Earth, except for the fact that we keep putting so many fossil fuels into it. So let me break down what I mean by that. So the greenhouse effect is what happens because of our atmosphere. So our atmosphere is what makes life possible on Earth. If we didn't have the atmosphere, everything would be below freezing. So what happens is that when the sun shines, hopefully this little animation is working. When the sun shines, it hits the Earth. Some of it is reflected, but some of it is absorbed. And so that's because of the atmosphere and the greenhouse effect. The atmosphere is almost like a sweater that keeps heat within the Earth. But what happens is that when we burn fossil fuels, we are basically turning up the thermostat in our greenhouse. So we are making the heat that is trapped, we are increasing the efficiency of how much heat is being trapped within the Earth. And so that is what is leading to climate change, is we are too effective at keeping heat in the atmosphere. So the reason, again, that climate change is happening and that temperatures are increasing because of the greenhouse effect is through the burning of fossil fuels. Also, a big thing, of course, in California is wildfires. So forests hold an enormous amount of carbon within them. And when forests burn, that also burns up a lot of carbon that is added to our larger emissions profiles. The production of oil and gas actually has, obviously the burning of oil and gas creates a lot of greenhouse gas emissions, but the production of it does as well. And that's because particularly with the production of gas, there are a lot of methane leaks, and methane is much more effective at trapping heat, even more so than carbon dioxide. A lot of other industrial activities lead to greenhouse gas emissions, including many agricultural practices, industrial practices, and also the way we deal with our garbage. The landfills have a lot of methane off-gassing that adds to emissions. All right. This is this graph actually has a California connection. So this graph is one of the most famous graphs within climate change science. It is called the Keeling curve, and it is taken at Mauna Loa Observatory in Hawaii, but it is part of the Scripps Oceanographic Institute at UC San Diego. And so what this started as was there was a scientist, I think his first name was Charles Keeling, who began measuring what's known as the annual carbon cycle at this observatory. And the reason it's at this remote observatory in Hawaii is because the instrumentation is like near the top of a mountain where there aren't any kind of industrial sources of carbon dioxide to interfere with it. What he was originally studying was during the course of the year, if you think about how plants grow and die back, especially in the Northern Hemisphere at very specific times of year, that plant cycle changes the amount of carbon dioxide concentrations in the atmosphere. So that's why when you're looking at the Keeling curve, you see it kind of bouncing up and down, almost like a heart rate, because there's like this annual cycle. But what Keeling began to observe over time is, even though that cycle was having a cyclical bouncing up and down, you notice that there's also a trend line going up. And so over time, we have reached these thresholds of new concentrations of carbon dioxide in the atmosphere that we have not gone back below. And so over the last, gosh, I forget when let me look a little closer at this. I guess within the last 10 years, I think, is when we cross the 400 parts per million of carbon dioxide, constant parts per million in the atmosphere. And we have not gone back below that since then. And to put that into context, we can look at, actually, I'm going to bounce around some slides here. So to put this into context, we can look at what we know about the atmosphere over the last hundreds of thousands of years. And the last time atmospheric carbon dioxide was at the levels that we have seen within this century was more than 300,000 years ago. So if you look on the right-hand side of the screen and you see kind of these two arrows, that's like when the Keeling curve starts. When the Keeling curve starts is at that lower arrow, and then it just keeps going all the way back up. So just to put this in context, this is how we know both like that what we are dealing with has never been seen before in any kind of recorded history, even like pre-human recorded history that we know of, or at least pre-modern humans, I should say. And so, yeah, it's not good. Let me go back a slide here, just to talk a little bit about something that sometimes you will hear from people who share disinformation or misinformation or false information about climate change. One of the things that you'll sometimes hear people say is, well, you know, the climate is always changing, so there's natural causes. And that is true to a certain degree, except it does not account for all of the warming. So what scientists have done, if you look on the graph on the right-hand side, is that scientists have basically modeled out, okay, if like you removed all human influence, if we had never had the Industrial Revolution and never discovered like, you know, burning coal for power, what would like climate change potentially look like based just on solar cycles and volcanic eruptions and whatever. And what you see is what would be in the blue area over here, right? So that would be like without the influence of humans. In the orange area is what is simulated because of human output. And then the actual observation matches what was simulated with adding greenhouse gas emissions created by human activity into it. So this is also the scientific evidence that we have for, you know, yes, like industrial human activity, burning fossil fuels is how we have gotten into the right-hand side of the graph. So that is the basic science that I always like people to have that understanding of. Okay, so we know that human activity, the burning of fossil fuels, is the unequivocal cause. And what does that mean? So what it means is that over the next century, we have already exceeded an additional 1 degree Celsius of global warming. And if we do not make major greenhouse gas reductions, those numbers will go higher to somewhere between 1.5 and 2 degrees Celsius. So this is why you're hearing a sense of increasing emergency from climate scientists who generally try to be very even-keeled in their public statements, saying that we really need massive reductions as soon as possible. And there's some emerging rhetoric that you will hear that is like the next decade is crucial. And that is because in order to make all of the reductions that we know we eventually need to make, we have to do as much as possible within this next decade. So what does preventing that additional warming look like? Well, this is where the next thing that you hear about quite often within the climate change space is two concepts that are closely related, but they are distinct. So the first is mitigation. So mitigation refers to what are we doing as, on whatever level you want to talk about, right? What are we talking about on the international level, the national level, corporate level, nonprofit level, our local communities, even our households? What are all of these collective entities doing to reduce the amount of greenhouse gas emissions going into the atmosphere? So that's what mitigation is about. Obviously, the biggest example of this is shifting from fossil fuel energy sources to renewables. So that's a big challenge, and that's where the whole concept of decarbonization comes from, which is finding ways to shift over our energy systems to renewables. But there's also a lot of other things that can and need to be done on the mitigation side beyond just shifting away from fossil fuels. So one of them is, to the extent that we have undeveloped areas of land, we need to try to keep those intact as much as possible, because especially when we think about places like forests or even large savannas that have natural grasses in them, those places lock in a lot of carbon. So you hear this a lot about like the Amazon rainforest. The Amazon rainforest is like the lungs of the earth, and it's because it takes in so much and expresses out, it kind of like cleans the earth quite a bit. It's known as a carbon sink. So when we lose those large areas of undeveloped land or forests, we kind of lose those places that are storing up carbon. And of course, this is, I think, really relevant to California, right? When there's wildfires that take out very large stands of forests. Obviously, fire is a very complex phenomenon, and for many centuries, indigenous communities were very used fire in very ways that were very integrated with what the land needed. But now, because we have lost those ways of managing land that are congruent with how it should be managed, it means that wildfires now are like often uncontrolled. They cause a lot of damage. They're releasing way more carbon into the atmosphere than the kind of controlled fire that used to exist on the land for many centuries before colonization. So that's just that's also, I just want to acknowledge that I am not a wildfire expert, because I have lived in the eastern half of the United States my whole life, but that's at least my limited understanding of the phenomenon of fire on the West Coast. Then the other thing that you hear besides mitigation is adaptation. So this is sort of the acknowledgement that even if we slam the brakes down on climate change today, or at least slam the brakes down on greenhouse gas emissions, that there are already some impacts that are going to be baked into the system that we will have to deal with. And a huge one is sea level rise. So even if we manage to cease all emissions tomorrow and have no more going forward, there's still going to be some sea level rise that is coming. And so what does adaptation look like? That looks like recognizing how we need to change our communities so that they can be responsive to climate change. So I'm guessing in parts of Southern California, this is probably less of an issue, but certainly in the eastern half of the United States, There are a lot of discussions about where it's appropriate to elevate buildings to account for flooding, having rainwater gardens or rainwater collection systems, because at least in my part of the United States, one of the things that we really struggle with is we're getting more severe rain events. And what that means is that our local sewer systems get overwhelmed because they were designed for a slightly drier climate than the much wetter one that we are now dealing with. And so there is a lot of emphasis within my region about changing impermeable concrete surfaces to like rainwater collection systems and other things to prevent water from, to prevent large rain events from overwhelming the system. So that would be a climate change adaptation measure. Okay, so yeah, I'm just seeing students. Yeah, and you know, the one thing that I am starting to learn about the Southern California environment is this whole concept of the atmospheric rivers, which Kim Stanley Robinson talks about a lot in his climate fiction novels. So yeah, like that's kind of terrifying too. All right, so climate change is leading to more frequent and more severe disasters, and we have everything from wildfires, hurricanes, precipitation events, heat waves, and droughts. But then we also have events where we are still learning about the connection between climate change and the prevalence of a particular event. So this is what's known as attribution science. And this is one of the areas of attribution science that I am keeping my eye on because it's relevant for my part of the country, is the link between climate change and tornadoes. So scientists have established very, very, very strong links between climate change and wildfires, climate change and hurricanes, climate change and all of the things you see on that list. But there's still a lot of unknown science about whether tornadic activity is more likely because of climate change or not. So that's one of those, like, the science is not totally 100% on this yet. But that's what the area of attribution science is about. Attribution science is trying to understand, like, you know, if you have like a Category 5 hurricane, how much of that was amplified because of climate change? So that's what attribution science is all about. We also know that beyond these particularly severe disaster events, that there are longer term trends. So a big one is ocean acidification. This doesn't get talked about as much as it should be, but it is it's a very, very serious part of climate change. Ocean acidification is happening because the ocean is also a huge carbon sink. And so just like the Amazon rainforest. And when it is absorbing so much of this excess carbon dioxide in the atmosphere, that means that the ocean over time is becoming more acidic. And that has very serious implications for the marine life of the oceans. It means that a lot of particularly fish populations are really struggling. And, you know, this isn't just like, oh, it's sad if the fish die. Like, this has very serious implications for people's livelihood, because so much of world hunger or world nutrition is sustained by fish and fishing stocks in the ocean. So if fishing stocks collapse in the ocean, this could have very serious implications for things like world hunger. And then the other aspect of this is sea level rise. So there's, my understanding of the most recent science is that there is sea level rise that is anticipated for California. It's not quite as severe as like the Gulf Coast or even parts of New England, but that doesn't mean it doesn't exist, right? Like the ocean is, you know, like the ocean is around the whole world, and so certainly there are going to be parts of California that do experience sea level rise. All right. And then, of course, climate change doesn't just impact the natural environment. We are part of the environment. Humans are not separate from the environment, so it also impacts us as well. The Intergovernmental Panel on Climate Change estimates that there are around 1 billion people in the world who are living in coastal areas. And this means that if you're in a coastal area, Snowden's saying she is, that all of this could have very serious impacts for your community and your livelihood. And of course, one of the things that we know is that climate change can exacerbate violent conflicts. There's a lot of studies that have suggested that the drought in Syria is part of the civil war there, and that was exacerbated by climate change. So this is something that a lot of people who study security issues and war are very concerned about, is how climate change can exacerbate existing tensions in communities. Obviously, people's physical health is very compromised when we have extreme heat. And one of the things, when I was talking earlier about how it's so important to protect areas of undeveloped land or waterways, frankly, too, is because animals continue to need places where they can thrive away from human development. There's a lot of speculation that as more habitat that is, undeveloped land kind of comes under development, that is bringing humans into more contact with wild animal populations. That has more potential for what's known as zoonotic diseases to make the animal human jump. And so a zoonotic disease is a disease that starts first within an animal population and makes the jump to humans. So there has been some speculation that zoonotic diseases could increase in the future, which could mean more future pandemics. And then, of course, this is all very traumatic. So this everyone's going to be impacted by climate change, but people who are dealing with existing issues of vulnerability and marginalization will feel it disproportionately. So there are a lot of mental health implications for this